By request, let's take a look at number 97 on page 116 that refers to an object that is free falling. They're giving us a position function here of negative 16t squared plus v naught times t plus s naught, where v naught is the initial velocity and s naught is the initial height. In this problem, we're dropping the object, or the silver dollar in this case, off the top of a building. So V naught is 0. And the height of the building is our initial height, and that is 1,362 feet. So the A wants to know, for our situation, what is the position function? So S of t equals negative 16t squared. The 0 wipes out the t, and then plus 1,362. So there's our position function. The other day I talked about velocity is change in position over change in time. And that's going to be the derivative of the position function. So we just get negative 32t in this case because the derivative of 1,362 is 0. So there is A. B wants us to find average velocity. So you need to think of average velocity between 2 points as slope of the secant line. So in this case, because it's over the interval 1 to 2, I'm going to do s of 2 minus s of 1 over 2 minus 1. And it's really important that you realize that that's what you're finding is just slope of the secant line between 2 points. So s of 2 would be negative 16 times 4, or 2 squared, plus 1,362. I'm going to go without a calculator as long as I can. S of 1 is negative 16 times 1, plus 1,362. All over 2 minus 1, which is just 1. The 1,362's cancel. I'm going to pull out a negative 16 and write 4 minus 1, and I get negative 48. They've already said that this is in terms of feet, and it's actually, even though I don't believe they say it, it's feet per second. So there's our average velocity. C takes us to instantaneous velocity. So I want you to make the connection here that average velocity is old-fashioned slope between 2 points, and instantaneous velocity is the derivative at 1 point. That's like your slope of your tangent line. So we're going to find V of 1, which is just negative 32 times 1. So that answer is negative 32 feet per second. And V of 2 is negative 32 times 2, which ends up being negative 64 feet per second. Remember that this is a silver dollar that is falling off of a building, and so your velocity should be negative because you're falling or you're traveling in a downward or a negative direction. D wants to know the time required for the coin to reach ground level. And so whenever something hits the ground, that's when its position, or its height in this case, is 0. So we're going to set negative 16 t squared plus 1,362 equal to 0. And if you subtract 1,362 and divide by negative 16, you get t squared equals 1,362 divided by 16. T equals plus or minus, but we're dealing with moving forward and positive time, so it's actually equal to the square root of 1,362 divided by 4 seconds. And I checked before doing the problem, and the square root of 1,362 cannot be simplified, and I think the back of the book writes a decimal. I obviously will take this answer. Then E wants to know what the velocity is when the silver dollar hits the ground. And so you have the time and you have the velocity. So it's V of square root of 1,362. And they really could have found a number that was a perfect square, but they didn't. So equals negative 32 times the square root of 1,362 divided by 4, and I guess I'll clean this up a little bit and say that's -8 times the square root of 1362 seconds. Again, when the silver dollar hits the ground, it's obviously moving in a downward direction, and its velocity, which is not seconds, is feet per second, is going to be negative when it goes splat and hits the pavement. Hope this helps. I will see you on Wednesday.